Welcome, everyone, to today's Explainer. So, if you're a high school student who's just starting out with coding, or honestly, anyone who wants to build a rock-solid foundation in programming, you are in exactly the right place. Today, we're going to focus on completely demystifying Python's conditional statements. We're going to take what looks like, super complex computer logic and break it right down into simple, manageable pieces. All right, let's dive right in.
So, what if your code could actually think for itself? It's a pretty wild question, right? Hooking a computer up to make its own decisions kind of sounds like science fiction. But I want to let you in on a little secret. Coding is absolutely not magic. It's really just teaching a computer how to make the exact same everyday choices that you and I make without even thinking about it. And the absolute core of that whole decision-making process is the if-else statement. Simply put, it's a fundamental tool that allows a program to choose between two completely different paths, all based on whether a specific condition is true or false. Think about it like a really simple daily decision. If you look out your window and it's raining, you take an umbrella, else you go without one. Honestly, you're already running if-else statements in your brain all day long.
Now, take a look at how beautifully plain English translates right into Python logic. Over on the left side, we've got our normal human thought: if it is raining, take an umbrella, else go without one. And then on the right, we have the Python pseudocode: if raining, umbrella, else nothing. Visually mapping this out really shows you just how intuitive the Python programming language actually is. It's literally designed to be readable, almost like you're just reading a book. But before we look at some real code, let's quickly lay out the golden rules, basically the grammar of this new language. Number 1, your condition must always evaluate to true or false. We call that a Boolean. Number 2, both your if statement and your else statement must end with a colon. Seriously, don't forget the colon. It is the #1 syntax error for beginners. Think of it as a trigger that tells Python, hey, get ready, an instruction is coming. Number 3, the else block, totally optional. You can just have an if all by itself. And number 4, only one of these blocks will ever actually execute. A computer isn't going to take the umbrella and leave it behind. It's always one or the other. Okay, I need you to pay super close attention to the number 4 here. Exactly 4 spaces of indentation is literally the difference between a working Python program and a completely broken one. Python is incredibly whitespace sensitive. It can definitely be a bit frustrating at first, but it forces you to keep things clean. After you drop in that colon we just talked about, the very next line must be indented exactly 4 spaces. That's how the computer knows that specific chunk of code belongs to that specific decision. Never forget those 4 spaces. Let's trace how the computer's brain actually processes this logical path step by step. First up, it looks right at the condition. Is it true or false? If the answer is an enthusiastic yes, meaning it evaluates to true, it immediately executes the if block. But if the answer is no, it evaluates to false, it completely ignores that if block. It completely bypasses it and skips straight down to execute the else block instead. And once that chosen path is taken, the program just happily continues on its way.
Section 1. The basic if-else.
Let's read through this awesome example, kind of like a conversation. Here, we're checking the legal voting age. We say, if age is greater than or equal to 18, and hey, notice that colon right at the end. Then, we drop down, use our mandatory 4 spaces of indentation, and tell it to print, you are eligible to vote. But else, another colon, we drop down, indent 4 spaces again, print, sorry, you cannot vote yet. So if your age variable is storing the number 20, the top block runs. If it's storing 16, the bottom block runs. See, it's just simple, clean logic. And this brings us to another super relatable scenario for high school, a student grading system. Right here, the variable marks is set to 72. Our condition asks if marks are greater than or equal to 40. Since 72 is for sure greater than 40, this evaluates to true. So Python dives right into that indented block and prints pass. Your score 72%. It completely 100% ignores the fail else block. Now, if the marks were, say, 30, that evaluation would be false and it would jump straight down to the fail block instead.
Section 2. Multiple choices with elif.
Enter the elif statement. Now, elif might sound a little funny, but it's really just Python shorthand for else if. It's what you use when you've got 3 or more outcomes on the exact same topic. Python basically acts as a chain of sequential checks here. It checks the first if. Is it false? Okay, it moves to the elif. Still false? It moves to the next one. And it keeps going in strict order, executing only the very first match it finds.
It's the absolute perfect tool for any multiple-choice scenario.
As a new student developer, you're essentially building a coding toolbox, right? And you need to know exactly which tool to pull out based on the problem in front of you. So, just 2 outcomes? Grab your standard if-else. Got 3 or more outcomes on a single topic, like a grading scale of A, B, C, D, or F? String together an if-elif-if. Just need to do something if a condition is true and do absolutely nothing at all if it's false? Use if alone. But what if you have conditions hidden inside of other conditions? Well, that brings us to our next tool, the nested if-else.
Section 3. Inception. Nested if-else. I want you to think of a nested if-else exactly like a video game. You have to beat the outer check, kind of like getting past the castle guards, before you can even face the inner check, which is your boss battle. If you fail at the castle guards, you never even see the boss. Your Python code works exactly the same way. Let's walk through this real-world job application example to see how it works. Notice the deep indentation levels here. They are absolutely crucial. First, we have the outer check. Are they between 21 and 35 years old? If that's true, we unlock the next level, the first inner check. Do they have a degree? If that's also true, we go one level deeper. Do they have at least 2 years of experience? Only if all 3 of these gates evaluate to true consecutively do we finally hit the jackpot and print eligible. If the applicant was, say, 40 years old, they fail that very first outer check, and Python completely skips all the rest of those nested blocks.
Section 4. The ultimate cheat sheet.
Wow, we've covered a ton of ground today, from basic true-false logic to multiple choice chains all the way down to nested inception logic. So here's a quick summary table that acts as your final study guide. Look at the key points here. If-else is your classic fork in the road, 2 paths, true or false. If-else handles your multiple paths, and remember, they are always checked in top to bottom order. Nested if-else is your video game logic, where the outer condition gates the inner check. And please remember the 2 most important grammatical rules for Python. You must always use 4-space indents to group your blocks, and you absolutely must put a colon after every single condition before you hit enter.
And that pretty much brings us to the end. You now understand the core decision-making mechanics of the Python language. Your code is no longer just a static list of commands, It can react, it can evaluate, and it can choose. So I want to leave you with this one question. Now that your code can think for itself, what real-world problem are you going to solve first? Will you build a grade calculator? Maybe a text-based adventure game? The logic is entirely in your hands now. Thanks so much for joining me on this explainer, and hey, happy coding!